Okay, so today we will be discussing input-output operations, input-output operations, and how to handle text files. Okay, so I have some introduction here. So a lot of times there will be a need to process data stored as text or output files to text. So you might need to process data that has been stored as text, or you might want to output a file or some data to text. So this is because text is a simple and quite convenient way of storing, retrieving, and sharing data. So due to this simplicity, it makes it easy for softwares to easily read text-based files. So for anybody that has worked in IT before or in any data-related capacity before, you will, I'm sure you must have seen a lot of instances where data is exported as either comma-separated file or normal text file, flat file. So the reason for that is you find it that Excel will easily interpret a data stored as text file. SQL database will easily interpret it. Programming softwares would also easily ingest such data. So many other applications will easily pass and read the content of a text-based file due to its simplicity. So it is this simplicity that has made text-based file quite widespread in use. Now, files stored as text represent a block of storage in memory. Let's go a little bit abstract. So how text-based files are represented in memory of computer. So each character represents a byte. So if you have done any computer class before, you should have been told that a byte of data consists of 8 bits. So a byte of data is meant to represent a character. For instance, the character A stored in the memory of computer, the computer uses 8 bytes to store it. So as an example, you can open up your notepad, type in any character, maybe one length character or maybe any arbitrary length of character. Take note of the length you have typed. Store the file, then go to the file location, right-click, and go to Properties. Check the size of that file. So you'll see that the size of that file is almost exactly going to be the length of the characters. So if you have 20 characters in that file, the file is going to give you 20 bytes. It's going to give you 20 bytes, most likely. If you have just one character, you're going to have 1 byte. So that is how characters are represented, at least on the very basic level. So characters are encoded as binary, but rendered as readable text in text viewers. So you, in secondary school or on the right mathematics, you must have learned binary numbers, about binary numbers, how to convert between base 2 to base 10 and all that. So you must have been told how this is the way computer stores data. Okay, so to make it a little bit intuitive for you to understand. So 1 byte is said to be 8 bits. This 8 bits is equivalent to 8 characters of binary. So let me write it out. So for instance, 8 bits is this length 0, 0, 0, 0, 0, 0, 0, 0. So there are 8 characters here. This is what 8 bits refers to. So the length here, the number of characters that can be represented by this length of this binary number or binary size is exactly 255. So you can represent 255 or 256 actually, 250, yeah, 255 characters. You can represent exactly 255 characters with this size of binary numbers. So for instance, letter A, for instance, can be represented in memory as 0001. I'm not saying that is, I'm just giving an instance. So take note of that. I'm just giving an instance. So for instance, this can represent letter A in memory. So if the computer wants to store letter B could be 000011. Letter C could be 100, and on and on and on. But take note that 255 different characters can be represented with this. And for ordinary English characters on your keyboard, this 255 is more than enough to represent all the characters that are available on your keyboard, and even more. So now, all data types can be stored as text. Take note of that. All data types can be stored as text. However, is it all data types that we store as text? The answer is no. And the reason is that there are some data types that, in order for them to be displayed properly, they need some special interpretation. They need some parts or some part of the file to tell the software that, okay, this is the way we're going to display this. As an example, if you save a file as .txt and you convert the extension, let me share my entire screen so I can display some of these things. Okay, so I want to open my notepad. So if you save a text-based file as doc, for instance, doc we know is my Word document. So let me say hello world. So here we have 11 characters. I'll save it, Control S, hello. I'm saving it first as .txt, as a normal text-based file. So I'm trying to access it on my system now. Oh, I can't find the, okay, yeah, it's here. Downloads. So I'll open the properties. And you can see it is exactly 11 bytes. Remember, I counted 11 characters. It's stored exactly as 11 bytes here. Each character representing 1 byte in memory. However, take note, the computer a lot of times needs to store some special characters. The explanation of that is beyond the scope of this class. I left a link there to a resource that you can still further explore to understand if you want to understand better how file storage is done. So there are some special characters that can actually take more than 1 byte to store. Take note of that. So I'm going to convert this file to, I'm going to save it as a document file. Save as. Okay, so .docx. I'm changing it to all files. So you realize that, so let's try to open it now. Sorry, this time is quite slow. Okay, so there's an error. What experienced an error trying to open this file? The reason is, fine, we can save it as text And we say text can be easily read by any software, or most softwares at least. However, there are some softwares that need some special information as header. They call it metadata. So the metadata is what describes some things about the document, such that if a software such as Microsoft Word, is trying to open the file, it first reads the metadata to understand how it's going to display the file. So text-based files are not able to offer that, except, yeah, they are typically not able to offer that. So that's one of the limitations of text-based files. So back to now. Anyways, you can still try to save a file as .doc, but obviously, you know, your document viewer, your Microsoft Word, or anything for that matter that use a document file might not be able to open it. So the common ways people save text-based files is .txt, which you can write anything to. We also have .csv, which is comma separated file. We have .tsv, tab separated, and I'm just adding this for fun. We are going to actually write to a .py file. So a .py file signifies that it is a Python type file. So we'll write that and we'll see some interesting stuff. Okay, so I'm going to delete this. So I have a note here. Files with any kind of extension can be written to text, whether okay, we have explained it. So this is the recommended material that I said you could consult, recommended read. Now, going to the syntax now, opening of files with open. So the function to open a text-based file is open. Files are opened as follows. So this is the syntax. Open, you pass in the file name. Take note that this file name refers to the absolute location where your file is stored. To make that clearer, so this file here, hello, is stored in PC/downloads. Let me actually open the file location so we can see it. Open file location. So this is stored in downloads. In order to get the absolute path of it, you can hold down Shift button and right click, and you'll see copy as path. Copy as path. I've copied it. Even though it's not going to open here, I'll paste it here for us to see what it looks like. File name. So it looks like this. It looks like this. Let me convert this to a code cell. Code cell. So this is how typically the file is going to, the path to the file or the file name parameter is going to look like. However, if the directory you are working in, there's something they call working directory. So on this environment I'm on, if I want to see the folder, the directory I'm working on, if I click on this at the left corner, it's going to load. Okay, it's trying to connect to my runtime. So I'll take you back to it once it connects. So this file name, take note, it is the path that connects to the file that you want to open. And the second parameter there is the mode. So how do you want to open this file? Is it as read? Is it just read access? Is it read and write access? Is it append? And so many others that we're going to discuss in this class. So here, this is where, this part where I am is the working directory for this environment I'm developing on. let me open my Jupyter notebook so that for those that would be using their Jupyter notebook on their system, they can know how to find their working directory. That's the way to open Jupyter notebook if you have it installed on your main Python. So as soon as it opens, I'll take you there. So the working directory, like I said, is the main directory, is the directory where your Python file is located. The directory where your Python file is located. If my Python file is located in downloads, then downloads is my working directory. So any file I want to open inside this download, I don't have to use this absolute path that leads to it. I can just simply say, remove this, remove everything here, and simply make use of this hello.txt. And it's going to, okay, so my Jupyter has opened, still coming up. So I can simply use this hello.txt, and we're going to do that a lot because we will be working with our main directory, our working directory here. So we won't need to specify the file path, but put it at the back of your mind that if you want to open a file that is stored elsewhere, that is not in your current working directory, you cannot use just the name alone. You have to copy the absolute path. Okay, so I'm going to comment this out because now some methods of a file object. So some methods of a file object. So when you open a file object, after opening a file as explained here, you can read the file with .read method. You can also read the file with .readline method, read lines, then you can write to that file with .write, and you can also close. In fact, it is essential that you close. So let's quickly summarize what each of these methods do. Read. So read reads all the content of a file as a chunk. It reads the specified number of bytes as a chunk. So if you don't pass any number, if you specify the number here, it's going to read that number of bytes. But if you don't specify any number, it will read everything as a chunk and display it on the screen for you, or pass it to any object variable. However, read line only reads a line of a text file, just a line at a time. Then we have read lines that reads all the lines in a file and converts each of them to an item in a list. Then we have write that simply writes characters to the text file. Then we have close, which I have said is very important. Any file you open, you must close it. If you don't close it, there are two likely effects that I know of. It's either the last write operation you do on the file does not reflect on it, or in the file rather, or yes, you lock the file for usage. What it means is any other person or even you would not be able to use that file. Say, for instance, you want to move the file to another directory, or you want to delete the file, or you want to, it's going to tell you that file is currently locked for use. So take note of always closing a file that is open. So now let's start with read mode of the file. Read mode simply opens the file for reading only. Now there's also a concept of pointer when you talk about reading and writing from files. Pointer is, as you know, when you open your Microsoft Office or your notepad, there's a pointer that tells you that this is where I currently am. So anything you type, types from there. Anything you delete, delete from there. So that pointer is also represented in the memory, or is also taken note of by the computer, even when you're doing read and write operations with your code. So now the pointer is placed at the beginning of the file here. This is the default mode for opening files. So as we go further, you're going to understand better how this pointer works. So now what you can do with this read mode. Remember I told you the function for opening a file is open. You call open and you pass in the name, the file name as an absolute path, or if it is your working directory, you can simply just use the name. So now I don't have any text file here. As you can see, there's nothing like text.txt. This could have been any other name. I just chose to use text. So I don't have anything. If I try to read it, it's not going to read. But before I do that, I'll try to upload a file that is named as text. Okay, let me pass in this hello file. So I've uploaded a file for the purpose of this class, and I'm going to rename it text.txt. So yeah, it has been renamed text.txt. So now I'm going to run this, and it simply opens and prints hello world. Take note, I said read 10 lines here. I've used 3 things here, or two operations rather. I've used the open operation and passed in the name of the file I want to open. Then I read the file and passed the output of that read operation into an object, a variable. Then I printed it out. So here I said read 10. If I wanted you to read just 5, the first 5, it's going to read just hello. And if I wanted you to read all, I'm just going to remove, I'm not going to pass any number into the read method. So that is open and that is read. So this is under what you can do in read mode. When you get you already have the notebook, I'm sure. So play around with modifying it and see what you get. Now the code below is the same as the code above. Take note that here I didn't pass the mode argument. I only passed the name. So here I'm going to pass the mode. I want it to be just read mode. And it does the same thing. It reads it and prints it out. The default mode for open is read. So without passing anything, I can read. Without passing whether it is read or any other mode for that matter, it's going to read accurately. So going forward, you can also use read lines to read multiple lines into a list. I want to do something. Let me open this file. I hope it saves. I'm trying to save it. I hope it has saved. Oh, good. Okay, so we're going to see read lines in action here. Notice I put 2 more lines so we can have multiple lines. So I already mentioned that read lines reads all the lines and passes each line as a list item in a list. So let's see it. So you can see you have hello world as an item. Then we have it is a good day. Then we also have thank you for joining this class. Everything in a single list. Now you can use read line to read one line at a time. Assuming you just want to read one line at just one time, so you make use of your read line. It's going to read just the first line here and print it out. So there you go. Hello world gets printed out. So what if I want to read another line? So I'll say out2 and call f dot read line the second time. So, and here, if I run it, it will first print out just out, and I can use another line to print out 2. It doesn't matter. I could have also printed it here as well, but I just chose to without any particular reason to use another line. So, hello world, it is a good day. That's out 2. If I wanted the third one, I would add it here. But as we go forward, you'll also see another way you can read, one line at a time, but ensure you read every line in the text file. Okay, so here, another line again. You know, we've read 2 lines before. Here, this one read 1 line, this read another line. And remember, there are 3 lines in the text file. So calling f.readLine the 3rd time here. This was the first f.read line, read the first one. This read the second line, and this is going to read the 3rd line. So, and it has printed it out for us. But what if I try to call it the 4th time and there's nothing inside? It's going to return empty, nothing. That's because there's nothing in the file. I can run it till eternity and nothing gets printed out. So let me run it again. So when you okay, so that is it. 5:30. Let's end this and resume back immediately using the other link. The other link is where you access this first link, just below it, you're going to find the second link there. Thank you.